Okay, so here we are with a rock is thrown off of a 5-meter cliff with initial velocity at 10 meters per second. You write the equation. This will be easy. Let's do this one as an example in your notes. Y equals is all you can start, or f of x. It's the same thing as y. And then, how do we always start? Negative 4.9x squared. That takes care of our gravitational constant and that little 1/2 at the beginning. Then we always add in the velocity right here. So what is it? 10x. And then we always add where we started. 5. So now you've written the equation for this. And you could do this with anything, a real thing. You would need to include some other factors that get complicated if you're going to include like wind speed or air resistance, or you can make it really complicated if you want. But all right, how high is the rock after 1 second? Should be 1 second. Well, that's telling me 1 second is telling me something important. Is that time or is that height? It's time. So time is 1 second. That means what is 1 second? X or Y? X. That's saying X equals 1. That's all they're saying. So I got to stick in a 1 and a 1. You can do that in your head. I bet you can. Very good. Comes out to 10.1. It's not that hard because the 1's just kind of like make the X's go away. All right, so final answer, 10.1 chickens. Or not. 10.1 what? Meters. Do be a little more careful with the units on this. Because 10.1 seconds would be totally different than 10.1 meters, right? So this is at 1 second, the rock, or whatever you're throwing off this little cliff, is 10.1 meters up. All right. Then, when does the rock land in the ocean? Or what's the name for this value? If the graph kind of looks like this, you can see where it hits the ocean, can't you? Right there. That's called a what? A root, or a 0. And you could get that by graphing it and finding it, or you could use the quadratic formula. I'm going to be focusing today on using the graph on the calculator. So would you please take your graphing calculator out and plug this into your graphing calculator screen. Okay, so once we have that in our calculator, here's what we do next. Hit graph, and now we can kind of know what this situation looks like. We're at, remember what we are, we're on top of a 5-meter, that's about 15 foot high, little cliff that's over the ocean, and you're tossing this thing upwards at with a velocity of 10 meters per second. That means it's going fairly fast when it leaves your hand. And it goes up, and it starts like right here, and it goes up for a while, and then it comes back down again, and it hits into the ocean right there. Okay. Now, if we're going to use the neato feature of the calculator, it's right here under second. Wait a minute. So I got to do that. Second, and right above the trace button is calculate. All right. So the 3 kinds of problems that they're going to ask you are, what if time is 2 seconds or whatever? Okay, well let's figure it out for that 1 second. We already know what the answer is, but let's show you how you could do it here. That's the value one. We're going to give a value to x. So push number 1. And now see how it's got an x equals and it's blinking in the corner there? X equals 1. Enter. Remember how we thought it was 10.1? There it is. It was under second, calculate the value, number 1, and give it an x value of 1, and hit enter. Get that? All right, here's the next thing you can do. Go back to second calc again. You remember the 0? The 0 is the same thing as the what? The roots. So if I want the roots, I go to that. So I arrow down to number 2, or I could just hit number 2. Enter. And now, this one's a little trickier. And this is a process, though, that you're going to use probably for the rest of your math life. Like as you go on into college and stuff, you use these same graphing calculators, and you use this method of finding the roots. It's really, really handy. And it also, and once you understand it, it's way faster than doing the quadratic formula. Because quadratic formula does the roots too, but so does this. All right, I know the roots are either here or here. And in this word problem here, that is actually in negative time. Anything to the left of the y-axis, or the y-axis there, is in negative time, so that's not possible. So I only want the root on the right. So it's asking me a question. Do you see the little question it says? Left bound. It wants me to show it where generally I'm looking for this root, because it knows there's two roots on the screen, and it wants to know which root do you want to find. And we got to get just to the left of that thing. So use your arrow keys and find your little spider. See my little spider on the screen there? Get the little spider just to the left of the spot that we're going to be checking. Okay, I know that seems like it's above it, but it's also to the left of it, just a little bit. And then you hit enter. And then I go a little farther past it to the right of it, because it's asking for a right boundary. I've just gone just a little bit past it to the right of it, and I hit enter again. And you hit enter one more time when it says guess, and now it tells you 0. See how it says 0 right there? And it says x equals this and y equals 0. So that's the way to figure out exactly where that is. 2.4562 blah blah blah. You probably could have even known that it was about 2.5, but you'd have never known it was 2.45 da 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 unless you use this feature. Okay? All right, so that's our 0, which means that y is 0, so the height is 0, and that must mean that x is the time. The time is 2.45 seconds. So at about 2.5 seconds, the thing hits the water. All right. There's one more thing this thing can do for us under calc. What's the other important spot? The maximum. Very good. Let's go down to maximum. Enter. And it's got the same process for this. You got to go to the left of it. Okay, I'm going to start that maximum over again because I had a calculator freeze up on me. So basically I get to the maximum one. I hit enter. Then I got to go to the left side. Pay attention now. Got to go to the left side of the maximum. The maximum point's at the very top of the little parabola there. Okay. I go to the left side of it. I hit enter. Then I arrow over to get to the right side of it. And then I hit enter. And then it asks me to guess, like, do you want me to actually do it between those 2 points? Hit enter, and that tells me the maximum. 1.02 and 10.1. Again, that was a maximum for this parabola. That means that x was the time was 1.02. After 1 second, or 1.02 seconds, it had attained a height of 10.1 meters. You get that? All right, so you always go to the left of it, then you go to the right of it, and then you hit enter one more time, and it'll tell you what the max is between those two spots. Because a calculator can find maxes on some polynomials have like 14 maxes. They got a whole bunch of little maximums. It wants to know the maximum between this and this spot is whatever. So it wants to know where on the graph do you want me to find the maximum. Okay, so I think this will all make the most sense once we're actually going through some homework. But these skills, this calculator skill of using calculate, it's right above trace, second trace, is going to be really, really handy for you to find zeros or to find, plugging in a number for x, evaluating functions. I think I might teach next year with like how to evaluate a function by using that too. All right, so let's get to your homework. The first homework problem is right here. So the equation for this one is going to start with y equals negative 4.9x squared, right? Because we're on Earth. You can assume that, by the way, if they don't tell you. And then plus, and this is where we put that velocity, so 44x. And then plus, this is where we put the height we start at, 200. There we go. After 4 seconds, how up is the ball? I would take my calculator, and I would type it in, and I would use value. Okay, let's see if we can get that up. So I got it in my calculator here, and I've got a value. I choose value. Uh-oh, and it graphed it. What is going on? Oh, there we go. And it wants a value for x. It wants it at 4 seconds, so I'm going to type in a 4. Enter. Did you get... Uh-oh, I messed up my equation. Let me go back to my y equals screen. I have 2200 on my equation. Oopsie. Got to delete that off. There, and now I go to... Okay, what's it supposed to be, 200? All right, sorry about that. There would have been a faster way, I know, but there, 2. 100. Okay. Second, calculate with the value of 4. Enter. 297.6. All right.